Right, here's our last example in 12.6 of solving exponential equations. These ones look also a little bit different than the ones we've seen before. They're all still exponential equations. You notice that we have a variable that is in the exponent, right? And so we've got to solve for x. Remember before, if we can get those bases to be the same, then our exponent should be equivalent also, and then we can set our exponents equal to each other. Now if you notice on both of these, and even the last one, we have some fractions now as exponents. And we still need to get our exponents to be the same. And a 5 and a 1 over 125 are definitely not the same base. So we have to somehow figure out how we can make them into the same base. Well, I'm looking at that 5 to the x, and I don't think I can break down 5 any more than it already is. So I'm a little bit stuck on that side. So let's maybe look at the right side. I do know that 125 is the same thing as 5 cubed, right? So could I say that 1 over 125 is the same thing as 1 over 5 cubed? And so now they're looking a little closer to be the same, but not quite. Almost. Well, we know that 1 over 5 cubed is really the same thing as 1/5 cubed, right? Because 1 cubed is 1, 5 cubed is 125, and so I haven't changed my value. I've just rewritten it in a different form. Now my bases still aren't the same though. I need the 5 and the 1/5 to be the same. So can I somehow get that 1/5 to turn into a 5? How can I get that 5 to flip, right? How can I get the 1/5 to be a 5 over 1? Well, I can flip it. And do you remember what happens when you flip? That exponent changes, doesn't it? If it were negative and you wanted to make it positive, wouldn't you change it and put it down to the bottom? So can I just use that technique and go opposite of that? If it's positive on the bottom and I want it to go up to the top, well, I can move my 5 up to the top and just make it a negative exponent. So now I have 5 to the x is equal to 5 to the negative 3. Now look, our bases are the same. And since our bases are both 5s now, regular 5s, not 1 5 and a 1/5, they're both 5s, I can set my exponents equal to each other, and I get x equals negative 3. All right, let's try b then. b has the same idea. We have 3 to the x is equal to 1 over 81. Definitely not the same base. And I can't break down 3 any more than it already is. So let's break down the 81. Well, I know that 81 is really the same thing as 3 to the 4th power. But I don't want a 1 over 3 and then a 3 over 1. Those aren't the same base. I want them to be the same base. Hopefully both whole numbers if I can help it. So I want to take this 3 to the 4th power that's on the bottom, and I want to try to bring it up to the top. When I bring that 3 to the positive 4 up to the top, it makes it 3 to the negative 4. Now look, I have the same base. And since the bases are both 3s, then my exponent should be the same. So then I can say that x equals negative 4. Kind of tricky, right? Let's try one more. Look at c. This one has variables on both sides in the exponent. My left side, the base is 1/2. My right side, my base is 8. Definitely not the same. I can change the 8 into 2 cubed, can I? And then I can take my 1 over 2, or 2 to the 1st power, bring it up to make it a 2 in the numerator so that my bases can be the same. When I do that, my exponent changes to a negative 1. So 1 over 2 is the same thing as 2 to the negative 1, right? And then 8 is the same thing as 2 cubed. And if you've noticed, that allowed me to make both of my bases just regular whole 2s. Since my bases are both 2s and they're equal, then my exponent should be equal now. So now I can take my exponents and set them equal to each other. I can distribute the negative 1 through, and I can distribute the 3 through. For my next step, I added 4x to both sides, and I subtracted 3 to both sides. I ended up getting negative 4 equals, did I make a mistake here? I said 2x, isn't it supposed to be 10x? So let me fix this. It's supposed to be equal to 10x. So then I can solve by dividing both sides, not by 2, but by 10. And then I can say that x equals negative 4/10. Let's reduce it and say x equals negative 2/5. Sorry about that. See, we all make little mistakes. You got to be really careful. I just noticed that. 6 plus 4 is 10x, and then I can divide both sides by 10. So x equals negative 2/5.